acceleration is defined as the change in velocity divided by the change in time, which is essentially final velocity minus initial velocity over final time minus initial time, or change in velocity over time. Okay, now the unit for acceleration, SI units, change in velocity, so that's a unit of velocity, meters per second, divided by time, divided by seconds. So that's meters per second squared. That's the SI unit. Since the acceleration is a difference between two vectors, it is also a vector. Difference between two vectors over time, so it is a vector. Like for velocity, if this time is small, then we have instantaneous acceleration. If this time is large, then we have average acceleration over that time. Different than you might think, we have three devices in the car that allow for the car to accelerate. What's called the accelerator pedal. That's when you press to try to speed up. That allows of the change of the magnitude of the velocity. So a change of the velocity, then we have an acceleration. Brake pedal, it again changes the magnitude of the velocity. If it changes the magnitude of the velocity, it changes the velocity. So then we have an acceleration. The more surprising probably is the steering wheel. The steering wheel changes the direction of the velocity. If you change the direction of the velocity, you change the velocity, so you have an acceleration. So whenever an object changes speed or direction, it accelerates. And these are the three devices in the car that allow for acceleration. Going back to the equation for acceleration, change in velocity over time. The velocity can change either in magnitude or direction. The minute we have a change, then we have an acceleration. Let's look at another form for the acceleration equation. Remember, the acceleration equation is change in velocity over change in time, or Vf minus Vi over t. That's the expression. Now, if we manipulate this a little bit, if we take this equation here, A is equal to Vf minus Vi over t, and multiply both sides by t, then we get At is equal to Vf minus Vi over t multiplied by t. The t cancels out, and then we are left with Vf, I'm switching the order, minus Vi is equal to At, and then add into both sides Vi, so that will give us Vf plus Vi minus Vi equals to At plus Vi. That's what we have here. Now, this equation, we'll use it quite a bit, and that's why I developed it here for you. Now, one more thing to pay attention to when we talk of acceleration is think of Newton's laws of motion. One of them, in particular, what we call Newton's second law. Look what it says. We'll go back to Newton's laws of motion later on. But for now, it says the sum of all external forces, which is called net external force. It's also called resultant external force. It's also called the unbalanced force acting on an object. So the sum of all forces acting on an object is equal to the mass of the object multiplied by its acceleration. So that net force is equal to the mass of the object times acceleration. The key here is, and that's why we have this here, to have an acceleration, I need to have a net force. I need to have unbalanced forces. If I don't have an unbalanced forces, or a net force that's non-zero, I don't have an acceleration. Acceleration needs a force. If you don't have a force, you don't have an acceleration. And the force, of course, it has to be unbalanced. Balanced forces do not result in acceleration. We need to have an unbalanced force to have an acceleration.